All right, Unit 1 Pre-Algebra, no packet with the blue cover out in front of you. Turn to the Cornell notes that in the upper left-hand corner you see 1.1. This is Unit 1, and this is the next lesson, so it is titled Powers and Exponents. Today's goal is I can create and evaluate numerical expressions using powers. Can you give me an example of what a power would look like in math? Could you give me an example in words that would have the word power in it? Not like, I've got the power, not like that. I'm talking about in the math world, right? We just came off of a lesson where we talked about math symbols, math words, and how they're important, and how being able to interpret these math symbols and math words, actually, it's super hard to complete a math problem without understanding the language. Power is a word in the math language. How would I read that expression? 2 to the little 5? No. I mean, literally, that's what it is. 2, and there's a little 5. But that's not how I read it in the math world. And if I look at that and I'm like, I don't know what to do with it, it's really hard to finish my math problem that it's involved with. I would read this as 2 to the 5th power. It is an expression. Why is it an expression, Mrs. Kluber? Because within that expression of 2 to the 5th power, you have numbers and there's an operation. It's hidden, but because of the way it looks, there's meaning behind it. 2 to the 5th power. The 5 in that expression, do you know what that's called? It's an exponent. All right, look at your notes. This is starting to look really similar to what should be in your notes, right? Go ahead and write 2 to the 5th power after the word power. Do you see how there's an arrow that comes out? Go ahead and write exponent because that 5 is the exponent in the expression. What does that make the 2? The base. Exponent and base are really important words when it comes to the math symbol power. Go ahead and fill in your notes that first chunk. But we're missing a part. What does this mean? What does 2 to the 5th power actually mean? Does it mean 2 times 5? Oh no. That is the biggest mistake that we make when we see exponents and we hear 2 to the 5th power. Exponents are a math operation. They represent repeated multiplication. The exponent tells you how many times your base is used as a factor. So what does 2 to the 5th power mean? Well, how many times should I see 2 in my multiplication problem? 5 times. Exponents are repeated multiplication. That is the operation. The exponent tells me how many times this 2 is being used as a factor. 1, 2, 3, 4, 5. Now we could take this a step further. Fill that in your notes first. We could say simplify 2 to the 5th power. And if we say simplify 2 to the 5th power, gosh, we gotta know what that word means. It means get 2 to the 5th power to its most simplest form. Would this be its most simplest form? No, we could evaluate this further, right? We could go 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. So we can do lots of different things with powers, but this is what this expression 2 to the 5th power means. So there are 2 special powers that I'm thinking about right now. And it has to do with to the 2nd power and to the 3rd power. What do you mean, Mrs. Kluber? What I mean is, instead of saying to the 2nd power, there's a special name that I can say instead. And actually a lot more people say this instead of 2nd power. Do you have an idea of what it is? Drum roll, please. Squared. Have you heard that before? Yes, you have. I know you have if you were with us last year in 6th grade. When we got into our geometry unit, man, how we labeled our answers, squared was a part of that. So if you see something like this expression, write this down. I'm in the 2nd chunk. So write squared on the line. And then write 4 to the 2nd power. Now, if you see that, you need to be aware that that can also be read as 4 squared. How can we read that? Say it with me. 4 squared. So squared is the special power when our exponent is 2. So now let's look at 4 squared. What does that mean? Let's write this in our notes. What does 4 squared mean? 4 times 4. The exponent 2 tells me how many times 4 is being used as a factor in my multiplication problem. Factors are part of multiplication problems. Now let's simplify 4 squared. We know it's 4 times 4, but what would it be in its most simplest form? 16. Nice work. All right, to the third power. Now, people don't necessarily say to the third power. They use a special name. Do you have an idea of what the special name could be for things to the third power? Drum roll, please. Cubed. I know you've heard cube before. If you see this expression, write cubed on the line, and then write the expression 4 to the third power. If you see 4 to the third power, you also need to recognize that I can read that as 4 cubed. What does 4 cubed mean? How many times is 4 being used as a factor in the expression? 3 times. Yeah, it means 4 times 4 times 4. Now simplify those expressions. 4 times 4 times 4, you can make it look a lot simpler. Well, we would go 4 times 4, which is 16, times 4, which is 64. Nice work. So make sure you have all of this in your notes so far. So let's review. There are 2 special power names. Instead of saying to the second power, we need to start saying squared. Instead of saying something to the third power, we need to say that something cubed. Think about this for a second, 7th graders. Why do we call things to the second power squared, and why can we call things to the third power cubed? Those have very geometric sounds to them, don't they? Why do you think? Right? Think of a square. All sides of a square are the same. So of course you're going to be multiplying the same number by the same number, right? Think of cubed. Cubed is made up of squares where all sides measure the same length. So of course you're going to be taking the same number times the same number times the same number, right? So when we're doing squared, really that's covering area. And when we're doing cubed, really that's covering volume. But it all stems from the geometric figure of a square because all sides on a square are the same. Exponents, powers represent repeated multiplication where you're taking the same value and you're multiplying it to itself. All right, with this lesson, I know I haven't said it, you can use a calculator. So if you want to get a calculator, you definitely can. If you're like, Miss Kluber, I can do this in my head, I got it, awesome. I just want to refresh your mind too on your calculator how to type in exponents. So you see our first problem is 2 to the 4th power. We know that 2 to the 4th power means 2 times 2 times 2 times 2. But we want to evaluate it. We want to simplify 2 to the 4th power. So in simplest form, it would be 16. So on your calculator, you can type the exponents in an expanded form, or you can use something like the caret key. And other calculators might have an exponent key where it shows you like x to the y, and you can use that. I'm going to use the caret key because I like that. So 2 is my base. I'm going to push the caret key, and that gets me up into exponent land. I'm going to type in 4. You can see we get the same answer. So 2 to the 4th power is 16. Let's do 2 to the 3rd power. You don't have to write anything down right now. Just do it with me. So 2 to the 3rd power, 8. 2 to the 2nd power, we know that one, 4. 2 to the 1st power, this one always throws people off. Remember, my exponent tells me how many times my base is being used as a factor. So here, 2 is being used as a factor once. It's just 2. 2 is the only problem, or the only factor on the page when we're doing 2 to the 1st power. 2 to the 0 power, 1. What? Okay, hold on. We also have the 3 here. Let's see if it works out the same with the 3. Remember, our goal here is to look for a pattern. So we have 3 to the 4th power. Let's write that down, or let's type that in here, 81. Type in 3 to the 3rd power. Okay, or you can do 3 times 3 times 3, 27. 3 to the 2nd power, oh, we know that one, 9. 3 to the 1st power, don't let it fool you, 3. How about 3 to the 0 power? What? How is it 1? I feel like it should be 0, right? You might be thinking the same thing. the 3's. If you go 81, you're taking away one of the factors in your multiplication problem, and that's a 3, right? So 81, the opposite of multiplying is dividing. 81 divided by 3 is 27. And 27 divided by 3 is 9. 9 divided by 3 is 3. 3 divided by 3 is 1. All right, so any number to the 0 power, what is it going to be? 1. Check these in your calculator. 6 to the 0 power is going to be 1. 10 to the 0 power is going to be 1. 19 to the 0 power, it's going to be 1. A million to the 0 power, it's going to be 1. Right? We got that by using our pattern back here. Right? We saw that. Now let's talk about this. 0 to the 0 power. What would happen if I type that in my calculator here? First of all, if you have the number 2 and you're going to divide it by 0, will that work? You have 2 Oreos that you want to share with 0 friends. How many will each of your 0 friends work? That doesn't make sense, you'd say, Miss Clover. That's right, because it's the divide by 0 error. So if my base number is 0, I'm going to be dividing by the base number every time, right? Divide by 0. Can you take 0 and divide it by 0? No, it's the divide by 0 error. Let's look. You might go, Miss Clover, watch this. 0 to the 0 power. Error. It does not exist. Or you can do 0 to the second power. It's just going to be 0. You can do 0 to the first power. It's just going to be 0. But here you would be going 0 divided by 0 when you do this. It does not exist because of the divide by 0 error. 0 to the 0 power is undefined. If you're unclear what undefined means, write this. It does not exist. Woo! It's been a long lesson. Remember, our overall goal is to be able to create and evaluate numerical expressions using powers. So that's what we're doing. Okay? We really want to focus on those 2 special powers. When we see the word cubed, we're going to think to the 3rd power. When we see squared, we're going to think to the 2nd power. All right? So here are your examples. You have 4 of them. I'm going to do one with you. You're going to do the remaining 3 and then come back and check your work. So 6 cubed, what would that be in exponent form? How you read it is how you're going to write it here. So exponent form would be 6 to the 3rd power, right? What is the value? So now you need to evaluate 6 to the 3rd power. In your calculator, you can use the exponent button, or you could type in 6 times 6 times 6, right? This is what you're going to be typing in your calculator, or you can use the exponent key. What do you get? What's the value? 216. Okay, so I'm looking for the exponent form and I'm looking for the value. Pause the video, do the remaining 3, come back and check your work. All right, so here are the answers. Now, what I have here off to the left, you do not need to have. That's either what you're typing in your calculator or you're using the exponent key. But remember, this is what 1 to the 5th power means. So go ahead and check your work, change any answers that you need to. That is our lesson for today.